Welcome students. Today we are going to study a new chapter, Limits and Derivatives, which is Introduction of Calculus. Calculus is branch of mathematics which deals with change of function with respect to change of values in its domain. It has got lot of applications in almost all engineering fields, different fields like economics also it is applied. Actually this branch is developed by two great mathematicians, Isaac Newton and Leibniz. Today we are going to start this chapter with a small topic, x tends to a and meaning of limits. Okay, so what is the meaning of x tends to a, which is denoted by the symbol. X tends to a means x takes values very near to a. It can be more than a or less than a, but it should be very near to a. For example, x tends to 2 means x takes values very near to 2. That means x can be 2.01. 2.01 is a value near to 2, or it can be 2.001. This number is nearer than 2.01, or it can be 2.00001, etc. So in this case, x is approaching to 2 from the right hand side of 2. So we denote by x tends to 2 plus. X can be less than 2 also. So x can be 1.999, or it can be 1.99999, etc. In this case, x is approaching to 2 from the left hand side of 2. So we denote that by x tends to 2 minus. So x tends to 2 plus means x is very near to 2, but it is more than 2. X tends to 2 minus means x is very near to 2, but it is less than 2. Now I will explain the meaning of limit x tends to a f of x equal to k. Limit x tends to a f of x equal to k means when x takes values very near to a, f of x takes values very near to k. Okay. For example, suppose we want to find the value of limit x tends to 2x. This means that x takes values very near to 2. We want to find 2x takes values very near to which number. Okay. So here f of x equal to 2x. Now first I will explain by using examples. So x is very near to 2. So I will take x equal to 2.1. When x equal to 2.1, what is the value of f of x? That is f of 2.1 you have to find. F of x is 2x. So f of 2.1 will be 2 into 2.1, that is 4.2. Now take one value nearer than 2.1, that is 2.01. And what about f of x? 2 into 2.01, that is 4.02. Let x equal to 2.001. So in this case, f of x is equal to 4.002. So what can you conclude from this observation? Here we can conclude that when x takes values very near to 2 from the right hand side of 2, f of x takes values very near to 4. That is, as x tends to 2 plus. 2 plus means x is near to 2, but it is more than 2. F of x converts to 4. That we can write like this. Limit x tends to 2 plus. F of x is 2x. That is equal to 4. Actually it is not equal to 4. It is defined like this. When x tends to 2 plus, 2x tends to 4. But we denote by using this symbol. That's all. Now we can take some numbers less than 2. That is, when x equal to 1.9, that is f of x. When x equal to 1.9, f of x equal to 2 into 1.9, that is 3.8. Okay. Now take one value which is greater than 1.9, that is 1.99, which is nearer than 1.9. So in that case, what is f of x? 1.99 into 2, that is 3.98. Okay, so x equal to, can take one more number, 1.999. So in that case, f of x is equal to 3.998 will get. So what is the conclusion? When x takes values very near to 2 from the left hand side of 2, function takes values very near to this 3.8, 3.98, 3.998. That means function is approaching to 4. Okay. Therefore, we can write like this. Limit x tends to 2 minus. Okay. What about 2x? 2x. When x takes values very near to 2 from the left hand side of 2, 2x takes values very near to 4. So, we will write equality symbol. Okay. So, this one is called right hand limit, RHL. And this one is left hand limit. So you can see that left hand limit is equal to right hand limit. So a limit exists if left hand limit is equal to right hand limit. Okay. So here you can see that LHL equal to RHL. That means left hand limit is equal to limit extends to 2 minus 2x is equal to right hand limit. And this limit extends to 2 plus 2x, and both value are equal to 4. Okay, so we can conclude that limit exists if limit extends to a minus f of x is equal to limit extends to a plus f of x. Okay, now consider the same question. Limit x tends to 2x. Actually, we need not go for example. We can find its value directly. How we can find? Just you have to substitute value of x in this function. So we will get answer. X is very near to 2 means it can be 1.999 or 2.0001. Both case, if it is x 1.999, what is actually value? It will be 3.999, etc. If value is 2.0001, 2x will be 4.0001. Anyway, in both cases, it is very near to 4. So just you have to substitute 2. So what is value? 4. You can find values directly without using examples. For the examination, you have to find the value in this way. Okay. Now we can do some problems. First one, evaluate limit x tends to 3, 3x plus 5. Means when x takes values very near to 3, we want to find the value of 3x plus 5. We want to find 3x plus 5 takes values very near to which number. How we can find? We need not take examples. It can be 3 minus or 3 plus. In both cases, we have to substitute x equal to 3. So what is the answer? It's equal to 3 into 3 plus 5. So answer is 9 plus 5 equal to 14, which means when x takes values very near to 3, 3x plus 5 takes values very near to 14. It is very near to 14. Okay. Take next question. Evaluate limit x tends to f of x. Okay. For f of x is equal to x square. When x is less than 2, equal to 2x when x is more than 2. Here, function is having two values. When x is less than 2, we are having f of x equal to x square. When x is more than 2, we have function f of x equal to 2x. Okay. So in this case, we have to find both left hand limit and right hand limit, because 2 minus means x is less than 2, 2 plus means x is more than 2. Okay. So first we can find left hand limit. What is left hand limit? Limit x tends to 2 minus. 2 minus means x is less than 2. So function you have to take as x square. Now we have to find this value. When x is very near to 2, x square will be very near to 4, because you have to substitute x equal to 2. Now we'll find RHL. That is limit x tends to 2 plus. 2 plus means x is more than 2. In that case, value of function is 2x. So, how we can find? This you have to substitute 2 in this function. So, value will be 2 into 2, 4. We can see that LSL is equal to RHL. Therefore, limit exists and value of function is equal to 4. So, we can conclude that limit exists and limit x tends to 2. 2 means can be 2 minus or 2 plus. In both case, what is value? Value equal to 4. Okay. So, if function is having more than one value, you have to go for LHL and RHL. Okay. Now consider another question. Evaluate limit x tends to 4 f of x, where f of x equal to 3x plus 4 when x is less than 4, equal to x plus 2 when x is more than 2. Here also function is having two values. So you have to go for LSL and RSL. Now what is LSL? Limit x tends to 4 minus when x is less than 4. Function should be 3x plus 4. Now what is value? This value equal to 12 plus 4 equal to 16. Okay. Now we can find RHL. That is limit x tends to 4 plus x is more than 4. So value function is x plus 2. Now we can find this value. For that, just substitute x equal to 4. We'll get 4 plus 2, 6. So you can see that LHL is not equal to RHL. So what is conclusion? Well, conclusion is one. Limit does not exist. We cannot find the value of limit. Okay. Next question. Evaluate. Limit x tends to 3 f of x, where f of x equal to 5x plus 3 when x is not equal to 3, equal to 6 when x equal to 3. Here also function is having different values. So you have to go for LSL and RSL. So what is LSL? Limit x tends to 3 minus. So which value we can take? Less than 3. Actually it is less than 3, but that symbol is not there. So we can apply the function. X is very near to 3, but it is not equal to 3. Less than 3. Less than 3 means not equal to 3. This function you have to take. 5x plus 3. For finding the value, this you have to substitute. So we get 15 plus 3 is equal to 18. Now we can go for RHL. That is limit x tends to 3 plus. 3 plus means very near to 3, but it is not equal to 3. Not equal to 3. So same function. So it is 18. So limit exists and is equal to 18. Okay. Let us consider another question. Suppose f of x equal to a plus bx when x is less than 1, equal to 4 when x equal to 1, equal to b minus ax when x is more than 1, and limit x tends to 1 f of x equal to f of 1. Then what are the possible values of a and b? Okay. We want to find the value of a and b given that limit exists and is equal to f of 1. Limit exists if LHL equal to RHL. So first we can find LHL. That is limit x tends to 1 minus okay, f of x. 1 minus means x is less than 1. So f of x is a plus bx. So what is value? Just substitute x equal to 1 is equal to a plus b. So LHL is a plus b. Now we can find RHL. That is x tends to 1 plus. 1 plus means x is more than 1. In that case, value of function is b minus ax. So b minus ax. After substituting x equal to 1, what will get? B minus a. It is given that limit exists and is equal to f of 1. So what about f of 1? X equal to 1. When x equal to 1, value of function is equal to 4. Now we can use definition of limit. LHL equal to RHL equal to f of 1. So we'll get a plus b equal to b minus a equal to 4. Okay. So we have two equations. First one is a plus b equal to 4 and second one is minus a plus b is equal to 4. This equation we can solve. How we can solve? Just we have to add 2b equal to 8. So value of b equal to 4. If we substitute value of b in any of the equation, what is the value of a? A equal to 0. So possible values of a and b are 0 and 4. Okay. Another question. Evaluate. Limit x tends to x square minus 4 by x minus 2. So when we substitute these values in this function, what will we get? We will get 2 square, that is 4, minus 4. What about denominator? X equal to 2 minus 2. We will get 0 by 0. What is 0 by 0? It is not defined. So in this case, we cannot write it as not defined because x is not actually equal to 2. It is very near to 2. It can be 2.01. If it is 2.01, this will be 2.01 square. 4.0, like that number will get. Denominator also 2.01. So you won't get 0 by 0. So we have to apply some other method. So here we can say that this one is 0 by 0 form. If function is 0 by 0 form, then we have to go for factorization. We have to factorize numerator and denominator. You have to cancel common term. After that, you have to find the value of function. Okay. So let us factorize. So limit x tends to 2. X square minus 4. How we can factorize? Just like a square minus b square. A minus b into a plus b. Okay. Denominator is x minus 2. So we can cancel this x minus 2. So this function changes to, this question changes to limit x tends to x plus 2. Now we can find this value very easily. Just substitute x equal to 2. We'll get 2 plus 2, 4. So this function converts to 4 when x takes values very near to 2. That is the answer. Okay. Let us do one more same type of question. Evaluate. Limit x tends to 3. X square minus 5x plus 6 by x minus 3. When we substitute x equal to 3, what will we get? Numerator will be 2, 3 square, 9 minus 5 into 3, that is 15 plus 6. By 3 minus 3 you will get. Okay. So it is minus 6 plus 6, 0 by 0. So it is not 0 by 0. We can say it as 0 by 0 form. So what you have to go for? You have to factorize. So how we can factorize? Numerator is a quadratic polynomial. So we can factorize this one very easily. You have to find two numbers, product equal to 6 and sum equal to minus 5. So two numbers are minus 2 and minus 3. Since coefficient of x square is 1, we can factorize directly. So two factors are x minus 2 and x minus 3 by x minus 3. So we can cancel these two terms and we can find this answer very easily. X minus 2, the substitute x equal to 3, we get 1. So when x takes values very near to 3, this function takes values very near to 1. Okay. Another important question. Evaluate limit x tends to 0 mod x by x. So actually here you have to use definition of mod x. What is mod x? Mod x equal to x when x is greater than or equal to 0. Mod x equal to minus of x when x is less than 0. X tends to 0 means x can be more than 0 or less than 0. Actually, this function is having two values. So we have to go for LHL. Limit x tends to 0 minus x is less than 0. Then mod x changes to minus of x. So this function changes to minus of x by x. That is limit x tends to 0 minus minus 1. This is a constant function. If you give any value for x, this won't change. So it is equal to minus 1. Now what about right hand limit? Limit x tends to 0 plus. 0 plus means x is more than 0. So mod x equal to x. So function changes to x by x. That is limit x tends to 0 plus 1. and value equal to 1. So LSL equal to minus 1 and RSL equal to plus 1. That means limit does not exist. Okay. These type of questions are important. Let us consider another question. That is limit x tends to x raised 5 minus 2 raised 5 by x minus 2. When x equal to, what will get? This will be equal to 2 raised 5 minus 2 raised 5 by 2 minus 2. This is actually 0 by 0 form. Now how we can factorize this one? This factorization is difficult, isn't it? So we are going to derive one formula. Limit x tends to a, x raised to n minus a raised to n by x minus a, same form, is equal to n into a raised to n minus 1. This formula will derive. So if you are using this formula, what is our answer? Our answer will be n, that is 5, into a raised to 2 raised to n minus 1, 4. So we get 5 into 16. 5 into 16 is equal to 80. Right? Now I will explain how we can derive this formula. X tends to a means x is very near to a. It can be more than a or less than a. Here I am taking x equal to a plus h, where h is a very small positive value. So actually x is more than a. I can take any value, it can be more than a or less than a. So if it is less than a, we will take a minus h. So by using this substitution, we will change this function. We will change this function. As x tends to a, when x takes values very near to a, h takes values very near to this. You can find from this equation. When x takes values very near to a, this equation changes to a equal to a plus h. So h equal to 0. So as x tends to a, h tends to 0. Okay. So by using this substitution, we can change this function as limit h tends to 0. Okay. What is x? X equal to a plus h whole raised to n minus a raised to n by x. A plus h minus a. So you can cancel this h. Denominator will be h. Now this one you can expand by using binomial expansion. Okay. So this will be limit h tends to 0. A plus b whole raised to n you are to use. So a raised to n plus nc1 into a raised to n minus 1 into b. Here b means h. Plus, what is third term? nc2 a raised to n minus 2 into h square. Plus etc. Plus etc. What about last term? B raised to n. B raised to n. Here it is h raised to n. This expansion of a plus h all raised to n. Minus this a raised to n. Okay. A raised to n. Whole divided by h. So you can cancel plus a raised to n minus a raised to n. Then from the all terms, all the remaining terms, here we have h as common. So take h as common. So we get limit h tends to 0, h into, if you take s from first term changes to nc1 a raised to n minus 1. Second term will be nc2 a raised to n minus 2 into h, etc. What about last term? H raised to n minus 1 whole divided by h. So we can cancel h. Now we have to substitute h equal to 0 in this function. So what we will get? Except first term, all other terms containing h. So all other terms will be 0. So our answer will be nc1 into a raised to n minus 1. What is nc1? nc1 equal to n. So n into a raised to n minus 1. That is derivation. So this formula you have to by heart. derivation you need not study. Limit x tends to a, x raised to n minus a raised to n by x minus a is equal to n into a raised to n minus 1. By using this formula, we can find this type of question, answer for this type of question very easily. So you have to compare these two. What about a that is equal to 2, n equal to 5. So answer is n into a raised to n minus 1. So answer should be n into means 5 into a raised to n minus 1. 5 into 2 raised 4 that is equal to 5 into 16 equal to 80. So we can find this type of question very easily by using this formula. Okay. By using the formula, we can do some more questions. First question, limit x tends to a, x raised 5 minus 4 raised 5 by x minus 4. Just you have to apply the formula, limit x tends to a, x raised to n minus a raised to n by x minus a. Just you have to compare. What about n? N equal to 5 and a equal to 4. Our answer will be 5 into 4 raised to n minus 1. What is 4? So 5 into 4 raised 4 means 16 and 16. That is 256. Now you have to multiply 256 into 5. That is 5 into 6, 30, 3, 8, 2, 10, 1, 2, 1, 2, 8, 0. Okay. Let us consider the question. Limit x tends to x raised to 10 minus 2 raised to 10 by x raised to 5 minus 2 raised to 5. Here also you are to use the same formula, but that x minus a term is not here. How we can make that x minus 2 term? Just you have to divide numerator and denominator with x minus 2. So we limit x tends to 2, x raised to 10 minus 2 raised to 10 by x minus 2 whole divided by x raised to 5 minus 2 raised to 5 by x minus 2. Now we can apply limit both numerator and denominator. So from the numerator we will get 10 into 2 raised to 9. Right? N into a raised to n minus 1. What about denominator? Here also we can apply the same limit. So this will be n into a raised to n minus 1, that is 4. So thus this one you can simplify. 10 by 5 equal to into 2 raised to 5 will get. Okay, that is 2 into 32, 64. Now we have to study two theorems without any proof. Actually, it doesn't need any proof. Theorem 1. Theorem 1. It states that if f of x and g of x are two real functions, satisfies the condition f of x less than or equal to g of x for all x, then limit x tends to a, f of x will be always less than or equal to limit x tends to a, g of x. If f of x is less than or equal to g of x, then if you take limit on both sides, inequality will be same. So if you are drawing graph of these two functions, it will be like this, right? F of x is always less than or equal to g of x. Suppose point is a. The next tends to a can be from the left hand side or right hand side. Value of f of x will be always less than or equal to g of x. Okay. Now theorem 2. Theorem 2. It states that if f of x, g of x and h of x are three functions, satisfies the condition f of x less than or equal to g of x less than or equal to h of x, and limit x tends to a, f of x is equal to limit x tends to a, h of x equal to L, then limit x tends to a, g of x is also equal to L. And its graph will be like this. We have three functions. F of x, okay, that is first function. Next one is g of x. Sometimes it can be equal. And third one is h of x. Okay, first one is f of x, g of x, h of x. F of x, we can write f of x, g of x, h of x. Suppose point is A. As x tends to A, if f of x is equal to h of x, limit, so this point is L, if limit x tends to a f of x equal to limit x tends to a h of x, in that case limit x tends to a g of x is also equal to L. So it will be at this point. Okay. This theorem is also called sandwich theorem. Now consider one question, that is limit x tends to 0 sin x by x. When x equals 0, this function changes to 0 by 0 form, right? Because sin 0 0 by 0, it is 0 by 0 form. But we cannot factorize. We have to go for some other method because it is not a polynomial. So actually we use geometry for finding this answer. So consider one circle. This is radius. You can see one triangle OAB and join AC. This is perpendicular to OA. This angle is x radian. From this figure, area of triangle OAC is less than area of sector OAC, right? Area of sector OAC is less than area of triangle OAB, right? OAB. So what is formula for area of triangle OAC? Half BH. Half into what is base? Base is OA and height equal to CD, right? Less than area of sector is half into r square theta, that is radius square theta. So here it will be half into what is radius OA square into theta means x, less than half BS, what is B? OA into height is AB. So now we can cancel the common term OA, half OA can cancel, half OA, then also we cancel half OA. So after cancelling half OA, we will get CD less than OA into X less than AB. Okay. Now what is CD? From this triangle OCD, sin x equal to CD by OC will get opposite by hypotenuse, that is CD by OA, because OC equal to OA. OC and OA are radius. So we'll get CD is equal to OA into sin x. Okay. Now for the triangle OAB, what is tan x? Tan x equal to opposite by adjacent, that is OA. So we get AB as AB equal to OA into tan x. Now we can substitute the value of CD and AB in this inequality. So we'll get OA into sin x less than OA into x less than OA into tan x. So we can cancel OA. So remaining terms are sin x less than x less than tan x. Now we can divide this expression with sin x. So we will get 1 less than x by sin x less than, what is tan x by sin x? That is 1 by cos x. After that, you have to take reciprocal of this inequality. If you take reciprocal, inequality reverse. So this expression changes to cos x less than sin x by x less than 1. Now take limit. So what will you get? Limit x tends to 0, cos x less than limit x tends 0, sin x by x less than limit x tends 0, 1. Limit x tends 0, cos x equal to cos 0, that is 1. What about upper limit? That is also 1. Therefore, by using sandwich theorem, we can say that limit x tends 0, sin x by x is equal to 1. Because lower limit equal to 1, upper limit equal to 1, therefore limit of function in between these two should be equal to 1 by sandwich theorem. Okay. So we have studied one important formula, that is limit x tends 0, sin x by x is equal to 1. So we can derive some more formula. What about limit x tends to 0, x by sin x? This is equal to, this one you can rewrite as limit x tends to 0, 1 by sin x by x, that is 1 by, denominator you can apply the limit, 1 by limit x tends to 0 sin x by x, that means this is result, 1 by 1 equal to 1. Therefore limit x tends to 0 sin x by x equal to 1 and limit x tends to 0 x by sin x also equal to 1. Now next result, limit x tends to 0 tan x by x. This one you can rewrite as limit x tends 0 sin x by x into 1 by cos x. Right. Now we can apply limit to first function and second function. So we'll get limit x tends 0 sin x by x into limit x tends 0 1 by cos x. So what about limit x tends 0 sin x by x? That is 1 into 1 by cos 0 equal to 1. So answer is 1. So limit x tends 0 tan x by x also equal to 1. Same way limit x tends 0 x by tan x will get answer as 1. What about limit x tends to 0 cos x by x? When x equals 0, numerator will be cos 0, 1. What about denominator? We get 0. 1 by 0 form. If we are getting a function as 1 by 0 form, we can say that limit does not exist because left hand limit won't be equal to right hand limit. This we can verify. What about left hand limit? Limit x tends to 0 minus cos x by x. This will be a negative value. Okay. Because cos minus x equal to cos x, but denominator will be negative. Now, right hand side, limit x tends to 0 plus cos x by x. X is very near to 0, but it is positive. So, numerator will be positive, denominator also positive. Positive by positive equal to a positive value. That means LHL not equal to RHL. That means if we are getting 1 by 0 form, we can directly say that limit does not exist. If you are getting 0 by 0 form, then you have to factorize 1 by 0 form, limit does not exist. 0 by 1 means limit will be equal to 0. Okay. Now we can do some problems by using the formulas. Limit x tends 0 sin x by x equal to 1 and limit x tends 0 tan x by x equal to 1. First question, evaluate. Limit x tends 0, sine 5x by x. Here you have to note down one thing. Limit x tends 0, sine x by x equal to 1 if these three variables are same. That means limit y tends 0, sine y by y will be equal to 1. Limit 5x tends 0, sine 5x by 5x will be equal to 1. So that you have to apply the result here. Here it is sine 5x. So denominator should be 5x. How we can convert denominator into 5x? You have to divide with 5. At the same time, you have to multiply with 5. Otherwise, question will be different. So limit x tends 0, sine 5x by 5x. Actually, I am dividing function with 5. So I have to multiply with 5. Okay. Now, as we know that as x tends 0, what about 5x? 5x also tends 0. It is very clear. Therefore, you need not write 5x tends 0 here. Okay. So, this limit we can rewrite as limit x tends 0, sine 5x by 5x into 5. Now we can apply the property of limit. Limit x tends 0, sine 5x by 5x will be equal to 1 into limit x tends 0, 5. 5 is a constant. If we give any value for x, it will be always equal to 5. So 5. So what about our answer? It's equal to 5. Now next question. Evaluate limit x tends 0, tan 5x by 3x. This one you can rewrite as limit x tends 0, 1 by 3 into tan 5x by x. Now we can apply the limit. Limit x tends 0, 1 by 3 into limit x tends 0, tan 5x by x. This is a constant. It is equal to, it will be equal to 1 by 3. Here you have to convert this one into 5x. How we can? So you have to divide with 5. At the same time, multiply it with 5. Now we can apply limit. So what we will get? 1 by 3 into limit x tends 0, tan 5x by 5x is equal to 1. Then into 5. So answer is 5 by 3. Okay. Next question. Evaluate limit x tends 0, sine 5x plus tan 8x by x. Here also you have to use same formula. How we can apply the formula here? We can split this one into sum of two functions. Limit x tends 0, sine 5x by x plus limit x tends 0, tan 8x by x. So next step we can write like this. Limit x tends 0, sine 5x. This is sine 5x. This should be 5x. So I am multiplying with 1 by 5. So you have to multiply with 5 also. Plus limit x tends 0, tan 8x. It should be 8x. So dividing with 8 and multiplying with 8. Okay. Now you can apply the limit. So first term will be sine 5x by 5x. 5x tends 0 because as x tends 0, 5x also tends 0. So 1 into 5 plus second term 8x by 8x. As 8x tends 0, it will be equal to 1. Okay. 1 into 8. Answer is 5 plus 8, 13. Now, next question. Evaluate limit x tends 0, sine 9x by sine 3x. How we can apply this formula? Here it is sine x by x. So this should be sine 9x by 9x. And denominator should be sine 3x by 3x. So we can divide numerator and denominator with x. So we'll get sine 9x by x whole divided by sine 3x by x. Now this x we can convert into 9 by dividing with the 9, multiplying with 9. This one you can convert into 3x by dividing with 3, multiplying with 3. Now we can apply limit on numerator and denominator. So we'll get limit x and 0 sine 9x by 9x. Okay, it will be equal to 1. Then into 9 because 9 is a constant. And denominator will be sine 3x by 3x. As x tends 0, 3x also tends 0. So limit 3x tends 0 sine 3x by 3x will be equal to 1 into limit x tends 0, 3. 3 is a constant. So we'll get 3. So 9 by 3 equal to 3. Let us do another question. Evaluate limit x tends 0 sine square 5x by x square. So we can apply same formula here. So first we can rewrite the question. Limit x tends 0. A square by b square is a by b whole square. That formula first we can apply. Sine 5x by x whole square. Okay. Now we can do the same method. Limit x tends 0 sine 5x should be 5x. So we'll divide with 5 into 5 should be inside the bracket that you have to note down. Now we can apply the limit here. So sine 5x by 5x as x tends 0 will be equal to 1 into, it's a constant, 5. There will be one square here. So what about answer? Will be equal to 25. Okay. Let us do another question. Evaluate limit x tends 0 1 minus cos 2x by x square. Now what is 1 minus cos 2x? 1 minus cos 2x is 2 sine square x. Right. 1 plus cos 2x is 2 cos square x. That formula to apply here. So this question we can rewrite as limit x tends 0 2 sine square x by x square. And this is equal to limit x tends 0 2 into sin x by x whole square. So we can write answer directly. First one is 2, then sin x by x 1 square equal to 1. So answer is 2. Okay. Let's answer the question. Evaluate limit x tends 0 ax plus x cos x by b sin x. Here also you have to apply same formula, that is sin x by x equal to 1. So this one is sin x. It should be sin x by x. For making sin x by x, you have to divide numerator and denominator with x. So limit x tends 0 ax plus x cos x by x whole divided by b into sin x by x. So we can cancel x from numerator. So we'll get limit x tends 0 a plus cos x, right, b into sin x by x. Now we can apply limit to each term. Limit x tends 0 a is a constant, it will be always equal to a. The limit x tends 0 cos x, it will be cos 0. What about cos 0? Cos 0 equal to 1 by b into limit x tends 0 sin x by x is equal to 1. So answer will be a plus 1 by b. Okay. Another question. Evaluate limit x tends 0 cos 2x minus 1 by cos x minus 1. Here you have to use the formula 1 minus cos 2x, 1 minus x. What is 1 minus cos 2x? 1 minus cos 2x is 2 sin square x. Therefore 1 minus cos x will be 2 sin square x by 2. That formula you have to apply here. So we can rewrite the question as limit x tends 0, 1 minus cos 2x by 1 minus cos x. Now we can apply that identity here. This will be 2 sine square x and denominator 2 sine square x by 2. We can cancel 2. Now we have to apply the formula sin x by x. So sin square x by x square should be here. The number should be sin square x by 2 by x by 2 whole square. So we can divide numerator and denominator with x square. So this formula, this question changes to limit x tends 0, sin square x by x square whole divided by sin square x by 2 by x square. Okay. So numerator will be sin x by x whole square, denominator sin x by 2 by x whole square. Here there is no problem. Sin x by x equal to 1. This one is x by 2. This term should be x by 2. So we can divide with 1 by 2, multiplying with 2. So there is no change in question. Now we can apply the limit. So this answer will be limit x tends 0, sin x by x, that is 1. 1 square equal to 1. What about denominator? Limit x tends 0. As x tends 0, x by 2 also tends 0. So there is no problem. Limit x by 2 tends 0, sin x by 2 by x by 2 equal to 1 into 1 by 2 will be there. Okay, because constant is 1 by 2. So answer is 1 by 1 by 2, that is 2. Next question is another type of question. Limit x tends to pi. It is pi sin pi minus x by pi into pi minus x. It's very simple actually. As x tends to pi, what about x minus pi? X minus pi tends to 0, right? That means pi minus x tends to 0. So this question we can rewrite as limit pi minus x tends to 0 sin pi minus x by pi minus x into this 1 by pi. Okay. Now we can apply the limit. Limit pi minus x and 0 sin pi minus x by pi minus x. These three variables are same. So it is equal to 1 into limit pi minus x tends 0 1 by pi. Since 1 by pi is a constant, it will be always equal to 1 by pi. The answer is 1 by pi. Another question. Evaluate. Limit x tends to pi by 2 tan 2x by x minus pi by 2. When we substitute x equal pi by 2, numerator changes to tan 2 into pi by 2, that is tan pi. Tan pi equal to 0. That means numerator is 0. And when we substitute x equal to denominator, we will get denominator as pi by 2 minus pi by 2 equal to 0. That means this function is 0 by 0 form. So how we can simplify? Since it is not equal to 0, we can apply one method. X tends to pi by 2 means x is very near to pi by 2. So we can take x equal to pi by 2 plus h or pi by 2 minus h. By using this substitution, we can change this function. Then as x tends to pi by 2, as x tends to pi by 2, this equation changes to pi by 2 equal to pi by 2 plus h. So h tends to 0. Okay, by using this result, we can rewrite the question as limit h tends to 0 tan 2 into x, x is pi by 2 plus h by x minus pi by 2, x minus pi by 2 equal to h. Now we can expand this bracket. So we will get limit h tends 0 tan pi plus 2h by h. Now what is tan pi plus 2h? Tan pi plus x is tan x. So tan pi plus 2h will be tan 2h. So last step I'll write here is equal to limit h tends 0 tan 2h by h. That's very simple. Limit h tends 0 tan 2h by 2h into. So tan 2h by 2h as 2h tends 0 is equal to 1 into, second one is a constant, so it is 2 itself. So answer is 1 into 2, that is 2. Okay. So dear students, this is all about limits. In the next class, we will study how to find derivative of a function and problems related with derivatives. Okay.